Okay, so today we're going 1-4 Introduction to Identities. We have these, you need to know them. I don't know what to say other than you need to know them. Okay, we already do know them. You didn't know they were identities, actually. And there's only 2 that you're going to learn new. Do you already know that the reciprocal of sine I wrote that wrong. Anyway, is cosecant, correct? So the reciprocal identity states that 1 over sine equals cosecant. Well, you already knew that, didn't you? Okay. We also know that the reciprocal of cosine is secant. So that means 1 over cosine equals secant. So what would 1 over cosecant equal?
Cosine.
Nope. Sine.
Oh, sorry.
And what would 1 over secant equal?
Cosine.
Cosine. What would 1 over tangent equal?
Cot or
Cotangent.
yeah.
And what does 1 over cotangent equal?
Tangent.
Now, these are if and only if, so that means 1 over sine equals cosecant. Cosecant equals what? 1 over sine. You can read this left to right or right to left. If you look in the book, they wrote the right and then the left, but doesn't matter?
No.
No. So these are what kind of identities? Reciprocal identities. I'm just going to go ahead and give you the other identities right now. They are ratio identities. So tangent of theta equals y over r, not y over r, y over x. So what function is y? What function uses y? In here. Sine. What function uses x? So it is actually sine over cosine. Well, we know that okay, so we know that tangent and cotangent are reciprocals of each other, yes? So that would mean cotangent, which is x over y, is what over what? Cosine over sine. Pretty easy.
Yeah.
Did you know all of this?
Yes.
You just didn't know these 2, but you really did already know them. You just didn't put them in that way. So they make it sound like, ooh, we got identities now. But are they hard? No. Do you need to know them? Yes. Like in your brain, when I say cotangent, you should be thinking 1 over tangent. Because I'm not going to remember cotangents. I'm going to remember tangents and then reciprocate them. Okay, so how we're going to use those today, it's going to say if sine of theta equals 3/5, then Cosecant is what?
Five over 3.
5 over 3. If cosine is negative the square root of 3 over 2, cotangent,
Negative 2 over 3.
Um,
Negative 2.
oh, not cotangent, secant, I was on the wrong one. It would be negative 2 over square root of 3, but we can't leave it like that, right?
Negative 2 square root of 3 over 3.
Negative 2 square root of 3 over 3. Now, when I do these, I do write them. If I'm going to have to rationalize it, I do write it, because if I went from secant to cosine, then I wouldn't have to, I don't want to reciprocate this, do you? No, because then you'd have to rationalize it. So if you just write the unrationalized and then do it, make sense?
Yeah.
Okay, do I have to write the if and then?
No.
Okay. So tangent of theta is 2. How about so? Cotangent of theta is 1/2. Secant of theta is 1. So cosine is 1. The reciprocal of 1 is 1, right? Okay, so cotangent of theta is negative 1. So tangent of theta is negative 1. Sine of theta is negative 3/5. And cosine of theta is 4/5. What's tangent?
Negative 3 over 4.
How'd you get negative 3 over 4?
Because that's the x and the y over 5.
Okay, well, technically we should put sine and cosine. Yes? You're right. So I'm just saying, okay, technically you should put sine over cosine, but then you'd multiply by the reciprocal, and when the denominators are the same, they reduce out, yes, and you would get negative 3/4. Now, Ainsley did it perfectly. She looked at it and she said, my denominators are the same, correct? So she just said this is x and this is y, so negative 3 over 4. Now, if the denominators weren't the same, could you do that? No. You would have to do this. So that's why I wanted to show you that. Or you could get common denominators and then do it, but this might be easier. Make sense?
Yes.
Okay. This is a side note. Sine squared of theta means sine of theta squared. Now we need to talk about that. Which one's neater, the left or the right?
Right. Left.
I think this is neater, myself. But this is what I'm doing. I'm going to take the sine and then square it. Okay, so I'm going to tell you that the sine of 30 degrees equals 1/2. Okay? That's what it equals. I'm telling you that. So the sine squared of 30 equals what? Well, the sine of 30 equals 1/2. So I'm going to take my answer and do what with it?
Square.
Square it. So it's 1/2 plus you. squared, which would be 1/4. Now, the reason why I did that is I didn't square 30 degrees, did I? You square the answer that you get. Bless you. Does that make sense? Because I'm not going to write that. That's gross. That's ugly. Ugh. This is nice and neat. This means this. Got it? They have another example. It's sine of theta equals 3/5. So sine squared of theta equals what? 3/5 squared, which would be 9/25. Do I need to do another one? Oh, I'll do this one just because. Cosine of theta equals 1/2. So what is the cosine cubed of theta? Anybody?
1/8.
1/8. How?
Because you cube.
You just cube it. Does it matter what I do? Change that number to? No. Okay. Pythagorean identities. You have to know these. Also. So they're called Pythagorean identities. So where did they come from? The what? From the Pythagorean theorem. So we're going to take the Pythagorean theorem. X squared plus y squared equals r squared. Because r is our hypotenuse, correct? And I want to make r squared 1. How would I make r squared 1? What would I multiply or divide it by? One times anything is itself, so that would give me r squared.
You would square root.
That would give me r. I want 1. How do I make a number 1? Can I multiply by something and get 1? No. Divide it by what?
R.
R squared.
R squared. Isn't that how we solve equations all the time? We divide by itself. So if we divide by r squared on the right, we have to do it on the what? Left. So both things on the left have to be divided by r squared. Well, this would be x over r squared plus y over r squared equals 1. Well, what is x over r? Cosine? Okay. So it's cosine squared. What's y over r? Sine.
Squared.
So sine squared. So your first Pythagorean identity is cosine squared plus sine squared equals 1. Kind of nice, isn't it? Okay. You're not going to have to do this ever again, but is it helpful to know where it comes from? Yeah. Okay. So what if I had x squared plus y squared equals r squared, and you want to solve for x or r? Which one? Which one you want to make? I mean, not x or r. X or y? Which one do you want to make 1? X. So to make x squared 1, I have to divide it by what?
X squared.
X squared. Well, that gives me 1 plus y over x squared equals r over x squared. Yeah? Well, what's y over x? Tangent. So 1 plus tangent squared. And what's r over x? Secant. So 1 plus tangent squared equals what? Secant squared. So there is another Pythagorean identity. Now, can I rewrite this? Can I move it around, both of them? Like if I over here, if I wanted just cosine, I could subtract sine squared and take the square root. If I wanted just sine, could I do the same thing? Well, could I take this and make it equal 1? I'd just subtract tangent squared, wouldn't I? So can I manipulate these to get what I want out of them? Yeah. So obviously the next one I'm going to do is divide everything by y squared, yes?
Yes.
And I would get x over y squared plus 1 equals r over y squared. So what's x over y? Cotangent squared plus 1 equals
Cosine. Not cosine. I can think of the
what's the
letters.
reason? Okay, y is what? And when you say y, you should either say sine or cosine. Which one? Sine. What's the reciprocal of sine?
Trying to think of the
CSC.
Yeah, I can think of the letters.
What it's called.
Yeah, I'll look back on that.
Cosecant squared. Okay, hint, guys. Look at all of these. Did I use any function twice?
No.
No, because you just said secant. Well, it's already used. Okay. Can I put 1 plus cotangent squared? Yeah. It's addition, yes? So these are all for the Pythagorean identities. And you're going to remember it's 1 plus tangent. And how are you going to remember secant? What's in the denominator of tangent? What function? X, which is cosine, yes? What's in the denominator over here? X, which is cosine. And the reciprocal of cosine is secant. That's how you're going to remember, because people get this one immediately. Got it. It's easy. Sine, cosine, right? That's how you're going to remember what goes with 1 plus tangent. Cosine's in the denominator, cosine's in the denominator. Because that's what we did. Didn't we put cosine in the denominator? Okay. And then over here, sine is in the denominator, so what? Sine is in the denominator. From here on out, anytime you see a squared function, where should your brain go?
There.
These. And you should say, how can I manipulate it? Or if I can, okay?
Why are you trying to turn us into manipulators?
What? You guys try to manipulate people all the time. So now I'm going to allow you to. If you don't know these, I would... Quizlet has flashcards. You could make flashcards. You need to know them. Okay? You have the reciprocal identities, the ratio identities, and the Pythagorean identities. From here on out, I expect you to know them. I expect calculus every day. I'm like, what identity is that? And they're like, Pythagorean. They gotta just, your brain has to go there. Now, it's not going to be immediate that you can recite them all. But from here on out, I expect you to be working towards. Does that make sense? Okay. How much time do we have? How far did we go today? 26?
9 through 12, 15 through 26.
Okay, so we need to do this. Okay. I didn't want to go further than we needed. Okay. So if sine equals 3 over 5 in quadrant 2, And it's important to say in which quadrant because you guys learned from yesterday that everything has two quadrants, yes? And if I don't tell you which quadrant, then you would have to give me two sets of answers, wouldn't you? So in quadrant 2, X is negative and Y is positive. So that's going to determine things, right? We are not making a triangle today. We are using identities to find the remaining trig functions. Now, when I say trig functions in your brain, are you going sine, cosine, tangent, secant, cosecant, cotangent? You should be. Okay, now, not all of them are find the remaining. Some are just like find sine, find cosine, but then others are find the remaining. So we might as well just do the remaining, right? With identities. So there is work. Got it? So we've got sine equals 3/5 already. Cosine, tangent. Okay, and then we're going to reciprocate those, right? Okay, so we are in the second quadrant. Sine is positive, so the other two functions have to be what? Negative. I'm already going to put a negative there. So what you do is you say, okay, well, I have sine and I need to get to cosine. What identity do you have that has sine and cosine only in it? You got reciprocal, ratio, and Pythagorean. Which one of those have sine and cosine only in it?
Pythagorean.
The Pythagorean. So, cosine squared plus sine squared equals 1, yes? And I put the negative because it's going to be negative. But I want to solve this for cosine. Yes? So how would I solve this for cosine? I'd subtract sine over and take the square root. So is it basically you're solving the Pythagorean theorem? Yeah. So negative the square root of 1 minus sine squared. I want to see this written on your paper. Got me? So negative the square root of 1 minus sine squared. I shouldn't have wrote tangent so close. So I have I don't know why I'm not using my other pens. So negative the square root of 1 minus, well, what was sine? 3/5. Can I just write 9/25? Okay. So 9/25. So I have to get common denominators, right?
Yes.
So this is 25 over 25. I'll put a little 25 there. So 25 minus 9. 16 over 25. So my answer is negative 4/5. Now, hopefully when you guys saw sine as 3/5 and saw 5 was the hypotenuse, you knew the other side was 4 immediately. Hopefully. Hopefully you get there. I did, but it says to use what? Identities. So I did that long one, right? Well, if I have sine and cosine, is there an identity that has sine, cosine, and tangent in it? Would it be a good idea to be writing these all on one piece of paper that you can have handy?
Yes.
Yes. Or just know them. Is there an identity between reciprocal, ratio, and Pythagorean that has sine, cosine, and tangent in it? They're reciprocal. Because no, not reciprocal, ratio. Because tangent is sine over cosine. So would it do you good to write these things today so you can remember them? The identities? Yes. Okay, well, sine over cosine. So 3/5 over negative 4/5. So it's going to be negative 3/4. And did we already know that it was going to be negative?
Yes.
Yep. So now that I have sine, cosine, and tangent, can I just use what? Which ones now? The reciprocal. So cosecant is 1 over sine. So the answer would be 5/3. You guys don't need me to write 1 over 3/5 and multiply by reciprocal, do you? No. Okay. And then secant of theta is 1 over cosine of theta. Don't forget your thetas, guys. So the answer is what? Negative 5 over 4. And if I had to draw that triangle, the negative isn't on the 5, it's on the what? 4, because radius is never negative. Yep. Cotangent of theta is 1 over tangent. Could we have also used cosine over sine? Could we use either one of those? Yep. Either way we do that, we would get negative. So, do I expect some work on this? Yeah. No triangles today. Now, I wrote this over here so I knew when I did my work, did the negatives come? Other than this one, right? But they came. Okay, do we need to do another one of these? Because they're long, right?
I think I get it.
Okay, so you're going to be using identities to manipulate stuff today.
So excited.
Should be. I'm so excited. You may not even get that far in them. So I guess if you wanted to start tomorrow's, because tomorrow's is this stuff. I got too excited.
Do we have more notes tomorrow?
No.